Hello, Advanced Algebra students. I hope you are having a fantastic day. We are going to continue on and doing our Chapter 5 notes. Today we're doing the notes for Section 5.2. So basically in our first lesson in Chapter 5, we learned how to rewrite radicals using rational exponents. Again, that just means an exponent with a fraction in it. We learned how to find roots, simplify radical expressions, and solve equations using rational exponents. Now we're going to build on these skills using properties of exponents that we already know from working with integer exponents. And we can use these properties to help us reduce as well as multiply complicated rational expressions. So I just wanted to remind you of a few rules related to exponents that you should already know. The first one is a product of powers. And that means that when I multiply two numbers with the same base, I can add their exponents. You don't need to write down the name of the property, just the rule would be a good idea. The quotient of powers property tells me that when I'm dividing, I want to subtract my exponents. The power of a power property tells me that I multiply the exponents. And then the power of a product property tells me that when I have more than one thing inside a parentheses, all raised to a power, that I can then distribute that power. Finally, the negative exponent property tells me that when I have a number to a negative exponent that is equivalent to 1 over that number to a positive exponent. Kind of a side note on there, if you did have a problem that looked like this, the answer would look like that. So both of those kind of work. Okay, so we are just going to do a bunch of examples using these properties during our notes today. So let's take a look at example number 1. Let's take 81 to the 5 6 times 81 to the negative 1/3. Now, because that is the same base, I know that the answer is just going to be the same base with the exponents added. However, as you know, anytime I'm adding two fractions, I do need to have the same denominator. So I'm going to make the denominator the same on that. So I'm going to rewrite this as 81 to the 5 6 minus, let's see here, 2 6. So this is going to be 81 to the 3 6. Now, if I reduce that fraction, 3 6 becomes 1/2. And that is simply asking me what is the square root of 89? So the answer is 9. I think that's kind of cool that that really nasty looking problem reduces down just to the number 9. Okay, let's look at example number 2. And again, feel free to pause anytime that you need to. If we were doing these notes together, I would probably go slower and you guys would have a chance to ask me to stop or whatever. But you can just push the pause button on the video instead if you'd like. In this case, I'm using the property right here where I'm taking a power of a power. So I need to multiply my exponents here. So I'm going to bring down the 2a to the 1/3. And then I'm going to think of this as a power of 1. So this is going to be a to the 2/3. And then b, when I multiply, 1/2 times 2/3. If you do the math here, these 2's cancel. It just becomes 1/3. Now, I do want to go ahead and add these exponents on the a. So I have a to the 1/3 plus 2/3, and then b to the 1/3. So this is 2a to the 1, b to the 1/3. And you can leave it like that if you want, or some people prefer to write that as 2a times the cubed root of b. But either one would be totally fine. All right, let's do another example. So for example number 3, xy cubed over x to the 1/2 And that is all being taken to the 2/3 power. So this is fairly complicated because they have to distribute that 2/3 to everything. So this is going to be x to the 2/3, and then y is going to be squared. If I take 3 times 2/3, these 3's cancel out and I just have a 2 there. So that's my numerator. And then on the denominator, I have x to the 1/2 times 2/3. Again, if I take 1/2 times 2/3, that cancel, and that's 1/3. Now, because I'm dividing here, I subtract my exponents. So this is gonna be x to the 2/3 minus 1/3 times y squared, or x to the 1/3 times y squared. And again, you can leave it that way if you'd like, or some people might prefer to write it y squared times the cube root of x. So both of those answers would be considered correct and equivalent. All right, make sure you take a screenshot if you need to do that. Let's go ahead and do a few more examples. Again, we're simplifying. And in a moment, we're also going to be multiplying expressions with rational exponents. This is typically considered one of the harder lessons, so that's why I'm trying to do quite a few examples. If I want to take the cubed root of 16x to the 5th, what I recommend you do is write out 16 as 4 2's, and then write out the x to the 5th as 5 x's. And then go ahead and notice that because it's a cubed root, I'm looking for groups of 3. So these two terms can come out. And I'm going to have 2x times the cube root of 2x squared. So this is a similar process to what we talked about in our last lesson. The difference is just that we have some things left in the radical. Okay, let's look at example number 5. I'm taking the 4th root of 81, a to the 8, b to the 5. Again, for me personally, I'm a visual learner and I like to write these out. 81 is 3 multiplied 4 times. A to the power of 8, I can think of as a squared times a squared times a squared times a squared. And then I've got 5 b's here. If I'm looking for groups of 4, I can take out a 3, an a squared, and a b. And it looks like I do have 1 b left inside the radical. So this is 3a squared b times the 4th root of 1b left inside there. You guys are doing awesome. I know that this lesson is kind of hard and I'm doing a lot of examples here, but I just figure since you're taking the time to watch the notes, it would be great if I could include basically one of every type that's on the homework so that you will know what to do when you get to those problems on your homework. Again, let's go ahead and write this out. I've got 4 x's on the top and 2 y's, and on the bottom I have 3 5's and an x, and this is all a cubed root. Notice that one of my x's cancels. An x on the top cancels with an x on the bottom. Then I can rewrite this problem as the cubed root of 3 x's and 2 y's here, and then the cubed root of 3 5's there. And let me draw a line between these problems here. All right. Then again, I'm looking for groups of 3, so I can take out an x and a 5. Notice that the y's cannot come out because there's only 2 of them. So this is going to be x times the cube root of y all over 5. Oh, and excuse me, cube root of y squared, because there's 2 y's left. Okay, let's keep going. You guys are doing fantastic. I'm going to probably go down to looking at what to do when we're adding and subtracting. So let's see, we need to find the reduced radical form of each expression. So let's have this be example number 7. So if I have square root of 20 minus cube root of 16 plus cube root of 250 minus radical 5. Now, in order to add or subtract radicals, they have to have the same, what we call radicand. That means the number inside the radical needs to be the same. So let's factor all of these to figure out what's going on. 20 is 2 times 2 times 5. 16 is 2 times 2 times 2 times 2. 250 is 5 times 5 times 5 times 2. And this 5 on the end can't be factored anymore, so we're good there. Notice that 2 of our radicals are cube roots and 2 of them are square roots. We also need to have what we call the same index, so we can only combine square roots with square roots and cube roots with cube roots. On this part of my problem, I'm looking for pairs. So I'm going to take that pair out, and on this part of the problem, I'm looking for groups of 3 because it's a cubed root. So this first term is going to become 2 times the square root of 5. The second term is going to be minus 2 times the cube root of 2. Then I'm going to have plus 5 times the cube root of 2. And then minus radical 5. I want to choose to think of this as minus 1 radical 5. Now we're going to combine like terms. 2 radical 5 minus 1 radical 5. It's just like saying 2x minus 1x. So 2 radical 5 minus 1 radical 5 would just be 1 radical 5 or just radical 5. Now notice that I have minus 2 of this thing here and plus 5 of that same thing. So I can think of 5 of these minus 2 of these would give me 3 of my cube root of 2's. So we're combining like terms just like we would with, say, x's and y's. All right, let's look at example number 8. If we want to multiply, we're going to be able to FOIL like we normally do. So let's do, for example, 2x minus radical 3 times 2x minus radical 3. I'm going to take 2x times 2x to get 4x squared. And then I'm going to have minus minus 2x radical 3. And then another negative 2x radical 3. And then remember that radical 3 times radical 3 is 3, and negative times negative is positive, so that's going to be plus 3. I can combine these two middle terms, so I'm going to get 4x squared minus 4x radical 3 plus 3. Okay, let's go ahead and do example 9. This one is shorter, but it's good practice for us. The cube root of 7 times 2 minus the cube root of 49. So again, we have to distribute just like we normally would. So I'm going to have 2 times the cube root of 7 for my first term. For the second one, notice that I've got a cube root of 7 times a cube root of 49. Because these are the same index, I can put everything under one radical symbol. So I can write this as 7 times 7 times 7 because 49 has 2 7s in it. Notice when I do that I now do have a group of 3. So this becomes 2 times the cube root of 7 minus 7. Okay, now we wanted for our last topic in our notes today, and I'm so glad you're watching the notes, by the way, because there's no way this is all going to fit on a crib sheet. We're going to talk about how to rationalize a binomial denominator. So let's say that I have 1 over 2 plus the square root of 5. As you probably remember, it's not okay to put a radical in the bottom of a fraction. So the way we get rid of it is to multiply by what we call its conjugate. So we'll make this 2 minus radical 5. When I multiply on the top, nothing changes. I still have 2 minus radical 5. On the bottom, I'm going to FOIL. So 2 times 2 is 4. 2 times, oh, this should be radical 5 here. 2 times negative radical 5, so that would be minus 2 radical 5. And my middle terms would be plus 2 radical 5. And then the last terms, positive times negative is negative. Radical 5 times radical 5 is just 5. These cancel out. 4 minus 5 is negative 1. So we get this answer here. Personally, I would divide both terms by negative 1 to simplify this, so it would be negative 2 plus the square root of 5. I'd like to do just one more example using that same process with a slightly more complicated problem. So let's say I have 5 minus radical 2 over 2 minus radical 3. Again, it's not okay to have a radical in the denominator, so I need to multiply by what we call the conjugate of the denominator. It has the same terms, but a different sign in the middle. This one's just a little harder because I do need to FOIL the top and the bottom. When I FOIL the top, I would get 5 times 2, which is 10, and then plus 5 radical 3, minus 2 radical 2, and then radical 2 times radical 3 is radical 6, so this would be minus radical 6. On the bottom, I'm going to take 2 times 2, which is 4, and then I have plus 2 radical 3, minus 2 radical 3, and then radical 3 times radical 3 is 3, and minus times positive is negative. These cancel out. 4 minus 3 is 1. So I have 10 plus 5 radical 3 minus 2 radical 2 minus radical 6 over 1. Personally, I would just take away that 1, and this would be my final answer. It's kind of annoying that you can't combine any like terms, but we really can't, because these radicands are all different. This is radical 3, radical 2, and radical 6, so none of those can be combined, and obviously the number can't be combined with the radical either. Okay, I'm so glad that you watched the notes. I think it probably will help you quite a bit, and I'll look forward to seeing you in class. Thank you.